Hello and welcome to Trace of All Trades. This is my project log for my molecular mass calculator that I wrote in Python. Here's that calculator. You can see when it boots up, it gives you instructions. You enter the molecule using the element symbol from the periodic table and subscripts if you need them. You use parentheses for molecules that have a coefficient or parentheses for molecules that are nested. So if you have a compound with an ionic compound inside of it, you can do that. If you have an invalid input, you'll get an error. You can type clear to clear this terminal, type exit to exit the program, or help displays this message. You can see here, if I type clear, it clears it, help brings it back, and exit, of course, exits it. So if I type an element like H2O, you can see there's the molecular mass of H2O. If I type this, which has lowercase letters, I see that those are not valid elements. If I type this and I put an invalid character, it'll catch that. If I put just a number, it'll tell me I need an element. If I put a leading zero, so H02O is technically still water, but you don't put leading zeros, so it catches that. If I put just a opening parentheses, it tells me it's missing the closing. If I put just a closing, it tells me I have an unmatched closing parentheses, and it tells me where that one is. If I put just parentheses, in either way, it throws an error. If I put a coefficient in front of it, you can see it calculates it like that, and it also supports subscripts. So either way, it would work. Um, it does throw an error when you do this. I know technically you can write water like this, but I just decided to code it so you had to use the parentheses. Um, it also works well for the nested molecules. So if I have calcium phosphate, it'll calculate that, and it's able to tell the difference between a subscript and a coefficient, like this 3 here, for example. It knows that that is the subscript for calcium, not the coefficient for phosphate. It also doesn't let you put the one in parentheses in front of the regular element, and honestly, the main reason for that was just because it wasn't calculating properly. Um, But here is the code itself. You can see here I have a large list or a dictionary of all 118 elements and their molecular masses, and that came from the IUPAC website. Here's a link there. I just used that periodic table to find them all. You can see here it has the big list of instructions that it prints out at the beginning, and then I have a whole bunch of functions here. I'll try to go through them one at a time. Here's the main calculator function. It starts off with a total of 0 and a fake element list of nothing. And then it takes an input and it finds all matches in the string that have a capital letter followed by 0 or 1 lowercase letters, and then as many numbers as you want or 0. Uh, so, if it's a capital letter and 0 lowercase letters, like hydrogen, that would work, or helium, where it's a capital letter and 1 lowercase letter, that would also work. If you put 2 lowercase letters, that's not going to work because it only takes 0, 1. But basically, it goes through all of those matches and it takes the number and it uses it and it puts it in the subscript variable. If there is no number, it just assigns a 1. And then it checks to see if that symbol actually exists in this dictionary up here, if it is an element. And if it is, it finds that spot in the dictionary to find its molecular mass, multiplies it by the subscript, and then puts it in this total variable. And it'll do that for every single match. So if I was to type in um, like hydrogen or oxygen, but if I type in both, it'll add them both together to get the weight of compounds. And then if it doesn't match anything in there, it'll just say that that's not a valid element, and it'll put it in this error list. And then here, this will find a lowercase letter that is not preceded by a capital letter, um, and that'll catch all invalid characters that shouldn't be there. Because obviously, like capital H lowercase e is helium, but if you just put lowercase e is not an element, and so it would catch that. And down here, it will return the value. If there's only one lowercase letter that's throwing the error, it'll say is, and if there's multiple, it'll say are, just to make it grammatically correct. Down here, this matches all characters that are not a capital letter, lowercase letter, a number, or parentheses. Those are the only things accepted, so everything else will throw an error. And you can see the same grammar function down there. Here, if the entire string matches a number, it'll just tell me that I didn't put any elements in my string. This one, if it finds that a number starts and then is followed by a capital letter, then it'll tell me I have missing parentheses. For leading zeros, if there's an element like a capital letter followed by 0, one lowercase letters, and then the number 0, and then some other number, it'll tell me that leading zeros are invalid. Down here, if the entire string is just parentheses, it'll tell me that that's invalid. For the matching parentheses one, there's this variable called balance, and so if there's an opening parentheses, balance increases by 1, and then if there's a closing parentheses, it'll decrease balance, and as long as it's 0, there's no error. If it's greater than 0, that means we had too many opening parentheses, and it tells me I'm missing closing parentheses. And here, if there's a closing parentheses and balance is equal to 0, meaning that this has not increased at all, then it's telling me there's an unmatched closing parentheses somewhere. And then the get total parentheses, it actually has a couple things built inside of it. It'll find if there's nested parentheses, because those aren't supported, so it'll just find a parentheses followed by something else, followed by another parentheses, and that'll catch all nested parentheses. Here, for coefficients, if there's a number and then an opening parentheses and then something inside that parentheses and then a closing parentheses, and that's the end, that's the whole thing, then it'll treat that as a coefficient, and it'll assign it into the variable coefficient. And then down here, it'll match where everything inside of parentheses are, and it'll find the subscripts outside the parentheses. Whenever it finds the parentheses stuff, it'll find inside of that, and it'll find the regular elements. This is the same code from the first calculation function to find just the basic elements, and then it calculates that, and then it'll multiply the whole thing by the coefficient if necessary, and that does the whole math for anything with parentheses. And then down here, if it finds a closing parentheses followed by some sort of numbers, if any, and then a capital letter, it tells me that there's an error there. I put an element inside of parentheses before just a regular element. And then down here's the main loop. You can see when it starts, it prints the instructions. It sees if you, or it tests to see if you type help exit or clear and then does the appropriate function. Down here, if there's not an opening or a closing parentheses, it'll run the regular get total function. If there is a opening and closing parentheses, it'll run the get total parentheses function, and that prevents it from giving me two totals and making sure it runs the correct calculations. And then down here, it'll make a variable, and it'll store the output of each function inside that variable. So this will basically run through all of the checks that I made up there. And then there's this list called errors, and it'll extend that list. And extend just means it adds to, and it extends with the contents of this variable. So if there's an error for one of the fake elements, it'll extend that to the error list, and if there's not, it'll add nothing. And so basically this down here, if there's something in the error list, it'll print each one of those errors. And if the error list is empty, meaning that none of these caused an error, then it'll print the regular total. If you want to see this code for yourself, to run it yourself, or just to read more in depth on the functions that I wrote, you can see that on my website. Other than that, that's all for now, and I thank you for watching.